Section 1.2 covers the Cartesian product. So we're going to start with the definition of an ordered pair. An ordered pair is a list written as parenthesis x, y, close parenthesis, of two things, x and y, that are enclosed in parentheses. Right, so what are the important parts of an ordered pair here? So we have that it's ordered, so the order matters, and it's a pair, so there's two things in the list. So before, when we were talking about sets, you could have any number of things. The order didn't matter. But now I want to think about order mattering, but I want to restrict myself to only having two objects. Right? So we're used to seeing things like this. Oops, wrong button. So I could have 1, 2 as an ordered pair. I can have 2, 1. I don't have to necessarily have each item in my pair being a number. So maybe I could have A, 2. And I could even have something like B, comma, 1, 3. So the second thing here is an ordered pair. I could have the first thing in my ordered pair be a set, and the second thing be also a set. Right, so the big defining characteristic here is that order matters, and there's only two things that are listed. Okay, so let's put some notes. So notes, order matters. So 1, 2 is not the same thing as 2, 1. And we should be careful with notation. So what do I mean by that? We've actually seen this notation being used before. So 1, 2 can mean ordered pair, or it's an open interval, right? So it could also mean the set of x and r, where x is strictly between 1 and 2. So it's that open interval. So we have to sort of decide which it is. We can determine which one it is by context. So that's the only thing we have to be a little bit careful about. All right, on here. Now that we've defined ordered pairs, we can use those to define the Cartesian product of any two sets. So the Cartesian product of two sets, A and B, is just another set. We denote it A cross B. We usually call it cross, or A Cartesian product B. And it's defined by A cross B is equal to the set of ordered pairs A comma B, where A comes from the first set and B comes from the second set. So let's think about what that looks like. So let's say maybe that A is a set of 1, 2. And B, let's have it have letters in it. Maybe that's A, B, C. So then A cross B is going to be any ordered pair where the first number comes from A, so it can be either 1 or 2, and the second entry comes from B, so it can be A, B, or C. So 1A is in there, 2A is in there, we could have 1B, we could have 2B, etc. So let's think about how we could represent this. One way to think about it is I could list out my elements of A. I could have 1 and 2 going down. And then I can list out my elements of B going over, little a, little b, little c. And then I can just think about all of the pairings between them. So I can have 1 and A. I can have 1 and B. I can have 1 and C. I can have 2 and A. I can have 2 and B. I can have 2 and C. So that set that has each of those elements in it, that's the Cartesian product of A and B. So what I want you to think about for class, what we'll start with is what is the size, what is the cardinality of A cross B, or A Cartesian product B. So think about that, and that'll be one of the questions we discuss at the beginning of class next time. So now that we've defined the Cartesian product, let's think about where we've seen it before. So what is R cross R? Well, R cross R is going to be the set of elements of ordered pairs, A comma B, where A is in R and B is in R. So that's going to be any ordered pair where the first element is going to be some real number and the second element is some real number, right? So we actually see this a lot. I can have 1 pi, 3, 7, right, 4, 5 over 287, right? I can have any ordered pair where I have a real number in the x-coordinate, it's usually what we call it, and a real number in the y-coordinate. So this is exactly the same as R2. So we're very familiar with these Cartesian products, right? They're exactly the different dimensional sort of spaces we've worked with before. So where can we go from here, right? We could talk about R3, R4, etc. So we'll think about how we can define those. I could also define something like n cross n. So then I'm going to have the set of maybe n comma m. We like to use letters near n when describing natural numbers, such that n is in n and m is also in n. So I could have my set of natural number coordinate or ordered pairs. So maybe if I want to represent that graphically, I can think about drawing it out. This is just going to be the grid of points. So 1, 1, 1, 2, 1, 3, 1, 4, going all the way up. 2, 1, 2, 2, 2, 3, 2, 4, going all the way up, and so forth. So that's my set, n cross n. It's going to be that whole grid of points. But only positive, remember, because n cross n, those n's are just natural numbers which are positive. Okay, so how do I actually go from R2 to higher things? Well, instead of just ordered pairs, I'm going to need things like ordered triples. So that's just when you have 3 things all together. Or ordered n tuples, where you have n things in your pair. So if I know what an ordered pair is, it's sort of easy to go to an ordered triple or an ordered n tuple or n tuple, you might hear it pronounced. So with that, I can define these higher Cartesian products. So I can say this is just going to be the set of objects little a1, little a2, all the way up to little a(n), where a1 comes from set a1, a2 comes from set a2, all the way down to an coming from set an. So I can take the Cartesian product of any finite number of sets. If each of the sets are equal to each other, then a to the nth power just means the Cartesian product of a n times. So this is where we get the idea of things like r cubed or r to the 4th. If you've dealt with complex numbers, maybe you've seen c, right? Think about a c to the 1st, c squared, etc. So these are the Cartesian products of these sets. So the set of those n tuples. All right, so finally there's a couple questions for you to think about. So go make sure you read through this section in the book, go back, re-watch any of the parts of this video that were kind of confusing to you, and then think about these following 2 questions. So if you have the Cartesian product of r, n, and z, is that the same as the Cartesian product of r with the Cartesian product of n cross z? So are those 2 sets the same? And is the set of, we'll remind you here that this is just 3 by 2 matrices. If I think of the set of 3 by 2 matrices, is that the same as R6? So as you're thinking about Cartesian products, these are the questions I want you to think about.